architect at Cisco, and he's part of the team which is responsible for leading data center and cloud solutions. Grex was part of the team which introduced some very innovative solutions within data cloud computing, and also multi-protocol label switching. His interest lies within data center, software-defined networking architectures, and service provider security and core IP networking solutions. And most recently, he co-authored a book called Cloud Computing and Automating a Virtualized Data Centre. Without further ado, please welcome Greg Page.
Thank you very much. Thank you for the plug. Good morning, everyone. It's a real privilege to be here. You guys are some of the brightest and best that we have in Europe, and by goodness, we need you to help with our productivity gap versus Asia and America and so forth. I hope you can all hear me. Can you hear me at the back okay? Yeah, excellent, good. So just to reiterate, my name is Greg Page. I'm a technical solutions architect. I've been working at Cisco for about 12 years now. And in that time, I've mainly been focused with what we call service provider security. Essentially being experts in reaction teams and so forth for mitigating things like distributed denial service attacks and so forth. So sort of stateless-based methodologies to fight against various attacks. So today I've been asked to talk a little bit about cloud. Specifically, what is it? Apparently, we all need to understand what cloud is. It's actually quite a difficult question, particularly when you've got a journalist, holding a microphone in your face. What is cloud? What would be your 30-second, sort of response to that? But I'm also going to talk not just about what is cloud and why is it relevant, why is it interesting. And I'm going to also talk about the relevance of networking to cloud as well. So the first half of our presentation is really around setting the context of cloud. The second half is talking about some of the more interesting areas in networking related to that. I'm not here today to sell Cisco products or anything, which is great for me. Normally, I speak to a room full of sort of 50-year-old men who are rather cynical and got a sort of CXO type title. So it's quite refreshing to talk to some new minds anyway. So as we go through the presentation, please stick up your hand if you want to ask a question. If I give you a funny look, it's probably I may not hear you correctly because I'm partially deaf. So just give me a second, I could probably repeat it again and I'll probably get it. Okay, so let's kick off. I've got a bit of sense of always do this. So, first thing, why are we interested in cloud and what is cloud? So first of all, we know the rate of change is growing exponentially all the time. People coming up with fresh new ideas, new different programming languages and so forth, allowing us to deliver capability, to support those ideas very quickly, rapidly. This particular slide has been used many times, and the usual question that gets asked with this particular picture is, do you understand the relationship between these two objects? And by the way, it's a really good thing if you don't. So does anyone not know what the relationship between those two objects is in this room? Yeah? We're all good? Yeah?
Fortunately, we're all old enough.
We're all old enough. Good, excellent. Yeah, I'm just trying to think, I'm not sure where the cut-off point would be.
It's going to be soon.
Soon, yes.
Yeah, it's going to be soon.
Yeah. I was listening to a presentation by a guy called Peter Hinson a few weeks ago. He's fantastic, this guy. He's a futurist. And he was telling a story of how his son was sort of saying to him, Daddy, his 80-year-old son, can I have a Facebook account? And his father was saying, no, you're too young. You can't have a Facebook account. So apparently his son did a really smart thing, which was go to his 13-year-old sister and say, hey sis, can you set me up a Facebook account, please? She said, yeah, sure. I'm not sure what the bargain was, but anyway, he got his Facebook account. And then he did a really stupid thing, which he made friends with his mum and dad, first thing. All right, so mum and dad were like, hey, turn that off. Anyway, obviously all hell breaks loose and the guy, his kid's bawling his eyes out, saying, oh please, I want my Facebook account. And part of sort of the diatribe coming from this kid was, how old were you when you got your Facebook account? It's like, but it's just to illustrate the point that how fast things are moving in our industry. So Cisco has something called the Virtual Networking Index. You can go to cisco.com, you can find it, you can generate your own reports for your projects, whatever you do. And essentially this allows us to forecast the amount of traffic that there is on the internet today. So Cisco is a company that not that many people have heard of, particularly lots of you will, obviously being in the industry. But globally, to an average consumer, they probably haven't heard of Cisco. But we are basically responsible for about 80% of routing and switching gear in the internet today. Slightly more, slightly less, given areas. So we actually can gather really good intelligence from tier 1, tier 2 service providers globally to paint this picture. And historically, this has actually been proven to be very accurate in terms of growth. And to give you some sort of idea of the rate of growth, it's pretty linear, as you can see, but quite substantial. In 2011, since the beginning of the internet, ARPANET, whatever, they estimate there was about 150 exabytes. Yeah, so that's 10 to the power of 18. Okay, so you've got petabytes 4, 10 to the power of 15, and so forth. So there's a tremendous amount of information. So, but also in terms of cloud, and I guess now would be a good point to sort of give you the definition of cloud as far as from my perspective, because everyone has a slightly different perspective of what it is. And essentially cloud is a new sort of operating paradigm. The ability to consume IT resources when and where you want it, in real time, and pay for only what you use. That's the basic definition of cloud. And normally, those services will be accessed over a wide area network of some sort, maybe internet or a managed private virtual private network as such. So we also have a cloud networking index now, and basically what we're looking at is the amount. This is actually the amount per year rather than per month. So we're now in the zettabyte era, effectively, in terms of the amount of data. And what we're looking at here is sort of traditional data that you'll find in an enterprise versus the amount of data that will be related to a cloud service. So again, you can see the top piece is growing much faster than the bottom. So we're seeing a real shift of not just consumers who are the first movers in the industry, but the larger enterprise and corporates moving into cloud services. Now, there's a lot of challenges for enterprises, corporations, to move their workloads into the cloud, and I'll be discussing some of those later. But it's not just about scale, okay? It's also about speed as well, and particularly some niche use cases. So if you go to the financial trading world, where we have closely coupled architecture, software architectures, latency is absolutely everything. Every millisecond counts, okay? So so in the past, we used to have switches about 18 microseconds, about 5 years ago, and a lot of those switches still exist today. And now today, this is the latest and greatest sort of switch from Cisco. I know I'm doing a product thing, but it's just to illustrate the point. We're down to warp mode here. If we turn on warp mode, that sounds a bit Star Trek-y, I admit. And it's 190 nanoseconds, okay, port-to-port latency. So that's incredibly low. Yeah? So something in the order of magnitude of 100 times faster in a couple of generations of ASICs and chips. So, out there in the industry, we see, consumers, all of us, are moving to our iPads, our iPhones, and so forth, using social media, and to support the scale needed for those services, the Googles, the Apples, the Amazons, are had to look at new ways of building their infrastructure to support that. Essentially, we describe this as scale-out architecture, as opposed to more traditional scale-up. So scale-up was all about, you have a computer, you put in as many CPUs, as much RAM as you can, and that was one single instance of the application. Scale-out is all about building out resilience in software architecture, but putting that over multiple nodes, and you scale out horizontally. So the processing power, and you treat all those different nodes as a single entity. I guess you lot are a pretty intelligent bunch. So who here has heard of the CAP theorem? Consistency, availability, partitioning. Anyone? Got one somewhere at the back. That's good. Anyone else? Really? Okay. So the idea is with the CAP theorem is you can only have two of the three. So you can have data consistency, and availability, but not if you have partitioning. And partitioning means essentially you have sort of a network between two compute nodes of the same application, for example, same database as an example. Yeah? So everyone's trying to find the holy grail between those 3 points of reference. And what we're seeing actually is a lot of this capability being moved towards sort of more enterprise and commercial space. And companies are very slow, really changing their IT methodologies and so forth, because they're so bogged down with not just technical but business processes, right? And the other problem with cloud is it is truly transformational in a lot of businesses. Because for the first time, rather than just aligning technical architecture and business architecture, and those processes, we're actually integrating those processes together. So when you bring in, you build a new cloud platform, in any entity, it's really transformational on the whole of the business. How do they go and procure new IT as a service? Or how do they support it? What are the support models? How do they organize their teams and so on and so forth? So there's a lot more than just technology involved in cloud. So the workspace is evolving. Today I turn up to my Mac. I can take that to work, and I can connect into my office, and I can download the applications that the corporation wants me to use. So I can connect with my own equipment, essentially. So the idea is, the bring your own device capability is a real hot topic at the moment. And we describe this as universal access, because essentially it's any content or any device accessing that content and capability from the cloud remotely. Another key area is sort of video. Video is an interesting area, particularly high def, and video is really one of the principal reasons you saw that huge growth in traffic. But it's all about this kind of what they describe as an immersive experience, the ability to talk to someone on the other side of the planet that you feel like you're right, adjacent to them. And that's one of the beauties of the internet, is creating that adjacency between participants. But also, everyone's just trying to be leaner and leaner in terms of their people. There's only a relatively small set of smart people like yourselves in the world, and everyone's trying to access that intellectual property quickly and efficiently as possible. So this whole idea of remote experts, etc., being able to invoke that individual as needed for a particular project in time and space required. I guess also on the cloud side, definitions around, have you heard of National Institute of Standards Technology, NIST, in the US? Most of you have, good. So most of you know that they have a sort of standard reference model that most people refer to in terms of the SPI model, which is software as a service, platform as a service, and infrastructure as a service. The easiest way to describe those is say infrastructure as a service, something you sell to a network administrator or IT administrator rather. The platform as a service is something you sell to a developer, and software as a service sell to a business. Simple as that. Really simple definitions to keep it. I guess not really connected to cloud, but it's interesting anyway because of the amount of data that's been generated. Is the marketing term big data? I guess most people here have heard of big data. Yeah? Okay. So the ability to look at, structured, semi-structured, unstructured data as one single set in real time and derive new, insights from that data using smart algorithms. And there's lots of companies popping up who have got, mathematicians, quants, whatever you like to call them, actually thinking about building these algorithms, but working hand in hand with various businesses and verticals to actually figure out what the inputs are to get the outputs that you need. So, elements of cloud computing. Okay, so as well as as sort of basic definitions. First of all, is the ability to self-serve. Yeah. So today, this is very much web-based, human-to-machine interaction. What we see going forward is more machine-to-machine, so API abstractions, the development of what we call cloud service brokers, the ability for a single orchestration system to effectively talk to multiple APIs of different cloud providers, provision infrastructure, and provision resources onto that infrastructure. This is really important. This is all about, from a consumer point of view, you really need to be constant about, the transparency of the information you're providing to the end customer. And that's normally accessed over the internet. And the idea is that, with a single click of the button, you can provision, your new virtual desktop or whatever it may be. Service delivery automation. So, as you heard, I've co-authored a book with a couple of mates of mine, and essentially, automation, intelligence. We've done automation data centers for years. You've got scripting routines and so forth, but actually, it's very difficult to manage those scripts and so forth over time. You have sort of an entropy problem effectively associated with that. So what we've built now is more intelligent automation or orchestration systems, allowing us to use what we call protocol adapters and so forth to connect into third-party systems with the appropriate semantics and the appropriate ontology and taxonomy to talk to those third-party systems. So the idea is that we can actually be event-driven here. We can actually instigate workflow and so forth based on information elements coming into the system. And dynamic resource allocation. So if I could highlight one big area of challenge today, particularly around sort of infrastructure as a service, would be capacity management. Yeah. So real-time capacity management. Previously, most systems in data centers and so forth were really built around a single source of truth, and they will have sort of eventual consistency with what's actually the underlying configuration of the infrastructure. So something called configuration management database, is where we hold all this information, in basically something called common information model, SIM. I guess most of you have heard of, yeah. Am I boring you yet? Okay, so essentially it's a well-known modeling language. And we can describe all the different elements in the infrastructure, but more importantly than that is the relationships between those elements. So if we have a failure in one of those elements, we can actually see the collateral impact upon the service owner, and from a business perspective, they say service level agreement, the whole world revolves around service level agreements. Okay. Resource management, again, it's being able to provision that, being able to understand what your capacity is, etc. We'll go into a little bit more detail around, infrastructure design, capacity planning, and traffic engineering, but more recently, things like optimization services or demand engineering. We'll talk a little bit more about that a bit later. And operational process. So this is your day-to-day. So this is where most people try and make savings, is the day-to-day, reducing the cost of change. So when we spin up a new machine, spin it down, etc., this is what we want to help achieve. So, the likes of Amazon, the likes of Google, we mentioned before, Susan was talking about, they have vast server farms, they have lots of smart people developing software and tools to allow them to do all these things and allow customers to interact with that web interface. The challenge is, how do you help lots and lots of different entities out there who don't have that intellectual property in-house to build this capability themselves? And it's really a question of different sort of abstraction models, and I'm going to talk a little bit about abstract models a bit later. Lastly, when your customer's interfacing with a web portal, obviously the lifecycle management is really important. So how do they upgrade their virtual machine? How do they switch it off, etc., etc.? All of these sort of things are really important. So when people start comparing different cloud systems, what they're actually really comparing is the portal interface. So really important for you to have a real world-class wireframer, the guy who understands presentation of the portal, the navigation structure of the portal, but also the underpinning information architecture as well. So, talk a little bit about the economics underpinning cloud. This actually comes from a website called Autonomics.com, and it's the sort of mathematical proof or certainty of cloud service adoption over time. Okay, so I'm going to take you through this. It was done by a guy who used to work at AT&T, started up his own business now. around sort of the cloud service broker area. I actually forgot his name, so I do apologize. I'm trying to remember that for later. Anyway, so the idea is there's basically 4 cornerstones to cloud economics, to keep it simple. The first one is the unit cost of delivery. Okay, so if you could build your own private cloud in-house, yeah, what can you produce? What's the unit cost of delivering a service versus consuming that service from an external cloud provider, i.e. a public cloud? And actually, the maths pretty much works out that, you know, the more you use, with shockingness, the more you use the public cloud, the more expensive it becomes. And actually, if you have a lot of workloads which don't vary in terms of their workloads, then actually it's better to build your own private cloud because it's more cost effective. And then obviously that leads on to the second part, which is, you know, workload variability. So effectively, you're looking at, you know, the difference between your average or baseline, you know, workloads versus your peak workloads. Okay, so peak and peak workloads. So you really, ideally, would want to build an infrastructure that has capacity for your baseline or your average workloads, and then be able to spill that additional workloads above that level onto a public cloud, so-called cloud bursting or whatever. Now, you know, some of the maths here is pretty simple. So, you know, as U stands for utility premium, how much you're willing to pay in addition above cost price for a cloud utility service. And it's looking basically, if you say, well, the peak divided by the average, you know, if it's less or greater than 1, then you should go for pay per use. So in other words, go and use the public cloud service. And then either way, you also have to look at the temporal constraints as well. So what's the frequency of those peaks as well? I was actually at a meeting yesterday in the building next door to, you know, the MI6 building on the Thames? Anyone know that? Yeah? The green glass building. The building next door is all charities. I didn't know that. All the charities are in this building, all the councils.